Acids and bases. This tutorial shows you how to determine the equilibrium position quantitatively. In this reaction, this is a Bronsted-Lowry equilibrium between two acids, hydrofluoric acid, HF, on the left, and cyanic acid, HCN, on the right of the equation. The equilibrium expression K equilibrium is shown on the right, where the K equilibrium is equal to the concentration of fluoride times the concentration of the cyanic acid is divided by the concentration of hydrofluoric acid, HF, times the concentration of the cyanide ion, Cn-. HF acid, hydrofluoric acid, loses a proton to give the fluoride ion, F-, its conjugate base. The acid dissociation reaction is given below, and the Ka equilibrium expression is shown on the right. Ka is equal to the products of the ions multiplied by each other divided by the acid concentration. Similarly, the HCN can lose a proton to give Cn negative. This is the reverse of the equilibrium reaction, the competing reaction between HF and HCN. The Ka acid dissociation expression is also shown on the right. There are now three equations, K equilibrium, Ka for HF, and Ka for HCN. The next slide will show you how this can be rearranged to determine the value of K equilibrium and the position of the equilibrium. Acids and bases. To determine the value of K equilibrium, we need to rearrange two mathematical equations, the Ka expression for HF and the Ka expression for HCN. To do this, Ka and the hydrogen ion concentration are isolated on one side of the equation, and the conjugate base divided by the acid is on the other side. The third equation is the K equilibrium. Substitute the Ka and hydrogen ion concentrations for the conjugate base and its acid. Note that the equation for the cyanide and its acid must be inverted. The hydrogen ion concentration cancel. This leaves the Ka for hydrofluoric acid divided by Ka for cyanic acid, HCN.